Okay, this is 6.1, ratios and rates. A ratio uses division to compare two quantities. So basically a ratio is a fraction, comparing the top quantity with the bottom quantity, or the numerator with the denominator by division. You can write the ratio of two quantities, A and B, as long as B is not equal to 0, in three different ways. Okay, the first way is this one. A colon B. Let me see if we can get a pen here. A colon B. Then we have A to B. Then we have A over B. Okay? Each of these are read the ratio of A to B. Now the ratio of B to A, I would have to flip the order. B would have to go first with each of these. Here B would be on top. They need to be written in simplest form. So in this case, let's say if I had 2 to 4, I would have to reduce that, and that would be 1 to 2. So just it's a fraction, remember, but even if it's not written in fraction form, it needs to be reduced. So if it can be reduced, if there's a number greater than 1 that goes into both of those, we need to reduce it, just as we would a fraction. Now, we'll never have a mixed number. We can always leave it improper. We just need to reduce it. Let's go back one here. Okay, tell whether the ratio is in simplest form. If not, write it in simplest form, then write the ratio in two other ways. Well, this one is not, because 8 and 6 have a GCF of 2. So I can divide by 2, and I can rewrite that as 4 to 3. I can write it in two other ways, 4 colon 3 and 4 to 3. I'm sorry, that is not correct. 4 over 3. I already wrote it that way. So I showed it reduced, then I wrote it in two other ways. 7 to 26, that is definitely reduced. Two other ways I can write that is 7 colon 26 and then 7 over 26. 39 to 13 is not reduced. 13 goes into both of those. That becomes 3 to 1, 3 colon 1. I can write that as 3 over 1, and I can write that as 3 to 1. Now, I do not want to make this just a whole number 3, because it is a ratio. We want to keep it in fraction form to show it is. Okay, 120 and 64. Well, we need to divide 120. Now, if you don't know, you can keep dividing by 2 until you get to its simplest form. Let's just do that. Let's go divide by 2. That's 60 and 32. Well, look, I can divide by 2 again. That would be 30 and 16. But I can divide by 2 again, and that gives me 15 to 8. Okay? So 8 actually went into both of those. 15 to 8, I can write that in two other forms, 15 over 8 and 15 to 8. Okay, 38 over 24 does reduce. We can divide by 2, that becomes 19 over 12. I can write that in two other ways, 19 to 12 and 19 colon 12. 17 over 5 is reduced. I'm just going to write it in two other ways, 17 colon 5 and 17 to 5. Okay, next page. Order the ratios from least to greatest. Okay, what we want to do is, I think the easiest way would be to change all of these to decimals. Okay, now remember, 2 to 9 can be rewritten as 2 over 9. And to make this a decimal, I just divide. 2 divided by 9, that is 0.2 repeating. Okay, 1 to 7 is the same as 1 over 7. If we know our FTEs, we don't have to have a calculator to do that. 0.142857, all repeating. Well, 7 over 28, if I reduce that, that's 1/4, and 1/4 is 0.25. 2 to 6, I reduce that to 1 to 3, or 1 over 3, which is 0.3 repeating. And then 3/10 is just 0.3. Now, order least to greatest. This is the smallest. 0.1 is definitely the smallest. Then I've got 0.2 repeating, 0.25, 0.3, and then 0.3 repeating. Look at the next one. 1 to 3, that's the same as 1 over 3. 1 over 3 is 0.3 repeating. Next one, 2/8, that's the same as 1/4. Well, 1/4 is 0.25. Okay, 5/18, that we're going to divide. We get 5 divided by 18. We get 0.27 repeating, with the 7 repeating. Okay, 7/20, well, 1/20 is 0.05, so 7 of those will be 0.35. 9/25ths, 1/25th is 0.04. 9 of those would be 0.36. Okay, order least to greatest. Well, it looks like 0.25 is the smallest, then 0.27 repeating, then 0.3 repeating, then 0.35, then 0.36. Okay, next. These are called unit rates. What we want to do is change each of these rates to a unit rate. Now, the difference between a rate and a ratio, a rate compares two units, two different units of measure. So here we've got words compared to minutes, miles compared to hours, dollars compared to people, wins compared to games. So a rate compares two units of measure. And to make it a unit rate, what we want to do is make the denominator 1. So with this first fraction, if I want to make the denominator 1, I have to divide the top and the bottom by 8. So that's going to give me something over 1 minute. Okay, 72 divided by 8 is 9. So I get 9 words over 1 minute. Or I can have 9 words per minute. That would work also. Okay, 150 over 25, I want to make the denominator 1, so I have to divide the top and the bottom by 25. I get 6 miles over 1 hour. Or I can write it like this, 6 miles per hour. Okay, 720 over 20, I want to divide the top and the bottom by 20 because I want to make the bottom 1. So it's 1 person. I don't want to put people, obviously, for 1 person. Then I want to divide 720 by 20, and I should get 36. That's $36 for 1 person. Here I'm going to divide by 10 because that's the denominator. So I get 1.6 wins per 1 game. Okay, and when it's a unit rate, I can have a decimal, even though I'm writing it as a fraction. You could also write it as 1.6 wins per game. 1.6 wins per game. Actually, that wouldn't make a whole lot of sense because if you only have 10 games and you have 16 wins, so I did something wrong here. It should be games, should be the other way around, or goals per game or something like that. Obviously, it doesn't make sense to have more wins than you have games, but we did the problem correctly anyway. Write the equivalent rate. Now, we've done this before. We have a rate. We've got miles per 1 hour, and we want to make that feet per 1 hour. Okay? Well, what did I lose and what did I gain? Well, I lost miles and I gained feet. So to cancel miles out, miles has to go on the bottom, feet go on top. The larger unit gets a 1 beside it. There are 5,280 of these in one of these. Then I simply multiply, and I should get 264,000 feet per hour. That's simple. That's simple. Next one, I have $58 for 1 day. Okay, what am I losing and what am I gaining? I'm losing days and I'm getting weeks. So I'm going to dollars for 1 week. That's supposed to be a K. Okay, so I'm losing days. I need days to cancel. Well, days is on the bottom. So to make it cancel, I need to put it on the opposite side on my fraction. So it goes on top. Week goes on bottom. Okay, so the bigger unit gets a 1 week, and that's how many days? 7. So you multiply 58 times 7, you get 7 times 8 is 56, 7 times 5 is 35, plus 5 be 406, $406 per week. Look at the next one. I got 440 feet for 1 minute, and I'm going to feet per hour. Okay, what am I getting rid of? Minutes. Okay, so minutes goes on top, feet go on bottom. No, I'm sorry. Yep, I'm getting rid of minutes and going to hours. Hours goes on bottom. Doesn't make sense to have minutes and feet. Okay, the larger unit gets a 1 beside it. There's 60 minutes in 1 hour. Now I simply multiply 440 times 60, and I get 26,400. Okay, the next one, I've got 70 meters to 30 seconds, and I'm going to go to meters per minute. Well, I've got 30 seconds, and I want to go to minutes. Well, how many seconds in a minute? Well, there's 60. What do I have to do to make this a minute down here? I can multiply by 2, which would be a pretty easy thing to do. If I didn't want to do that, I would make this a unit rate. Okay, so I could make that 2.3 repeating over 1 second. Okay, and I want to get rid of seconds and go to minutes. 1 minute, 60 seconds. That's going to equal, multiply that out. Well, that would equal 140 when I do that. 140 miles per minute. Okay, same thing here. If I multiply this by 2, I get 1 minute. So multiply that by 2, I get 140. Okay, works either way. Next, the store sells cookies, 16 cookies for $11.88. Find the cost per cookie. Well, this tells us how to set up our ratio, our rate. Okay, the cost goes on top, cost first, cookie goes on bottom. Okay, now I need to find out the cost per cookie, so I need a unit rate. So I'm going to do like I did earlier. I'm going to divide the top and the bottom by 16. Okay, we'll need a calculator for this. 11.88 divided by 16. That's 0.7425. Since we're talking about money, it's going to be 74 cents for one cookie. And that is done. Let this tell you how exactly to set up your ratio. Cost goes on top, cookie on bottom. Okay, an aquarium has twice as many angelfish as goldfish. The aquarium contains only angelfish and goldfish. Write a ratio for the number of goldfish to the total number of fish in the aquarium. But let's look at goldfish to angelfish, or angelfish to goldfish. If there's twice as many angelfish as there is goldfish, then the ratio of angelfish to goldfish is 2 to 1. The ratio of goldfish to angelfish, I would just change that around, 1 to 2. But they're not asking for that. They're asking for the number of goldfish to the total number of fish. So this still represents the number of goldfish, but the total number is gotten by adding these two together. So it would be 1 to 3. So 1 to 3 would be our answer. And that would take care of what we need to do today.